Hi class, today we are on Saxon Math Book 3, Lesson 66, and we're going to talk about parallelograms. So before I get started with what a parallelogram is, I want you to show me with your hands or your arms, what is parallel? Hopefully, you're holding your arms like this, so that they're the same distance across. They're never going to intersect, even if they went on forever and ever. This is not parallel. This is not parallel. Just like this, same distance across. Those are parallel arms. We can remember that by looking at the pair of L's in the word parallel. We've got two parallel L's in parallel. So, a parallelogram is a shape in which the opposite sides are parallel. Always, all sets of opposite sides. So here I have some examples of parallelograms. You'll notice right here, there's a set of parallel sides, and then here is a set of parallel sides. Same thing on this one. We have parallel sides horizontally and parallel sides vertically. Same here, parallel sides, and then this one here, parallel and parallel. Opposite sides are always parallel in a parallelogram. So you might see a shape that looks like this. So far, so good, right? I've got a set of parallel sides, but when I close this shape, these two sides are not parallel, which means this is not a parallelogram. Not a parallelogram. In a parallelogram, both sets of opposite sides have to be parallel. So if one set is not parallel, then the whole thing is not a parallelogram. So, some types of questions that you might see concerning parallelograms is maybe they give you the measurements and they tell you this is 2 inches and this is 4 inches, and they might say, find the perimeter to this parallelogram. Well, just like a rectangle or a square, not only are my opposite sides parallel, but in a parallelogram, my opposite sides are going to be the same length. So if this is 2 inches, this one is also going to be 2 inches. If this is 4 inches, its opposite side will also be 4 inches. So now remind me, how do we find the perimeter of a shape? Oh, right, we add up all the sides. So to find the perimeter here, we would have to add 4 plus 2 plus 4 plus 2. So we've got 4, 8, 10, 12, and my units are inches. So the perimeter, we can write P equals 12 inches for this shape. Another example you might have, we'll look at this same picture here, is they might ask to describe the angles. Now, if they do that, they're going to label the angles. So let me get rid of the measurements here so that we can just look at the angles. They would label by putting a little dot in the vertex, and they might call this A, B, C, D. And then they want you to describe the angles. Well, gee, how do I describe an angle? If you remember from just 1 or 2 lessons ago, we talked about the different types of angles there are. So we have acute little angles. Which of my angles here are acute? We call them by whatever letter is next to the angle. So my acute little angles here are A and C. A and C are acute. Do I have any right angles in this shape? Nope, we don't have any square corners, which means we don't have any right angles. Do I have big obtuse angles in this shape? Yes, there's two of them. B and D are both obtuse. Okay, so we are going to move on to the lesson practice. If you want to follow along with me, it is in your book on page 358. The first one says, draw a parallelogram that does not have right angles. So I can't check yours. I would like for a homeschool teacher to look at this problem and tell you, does that parallelogram have right angles? But the type that you're looking for is a tilty parallelogram, because your rectangular parallelogram and your square parallelogram, those are going to have right angles. So here's how I draw one with no right angles. I start out with my top horizontal line, and then I can either go here or here. It doesn't matter where you want to go. Usually I go left to right, and I make a slanted line connecting to that corner. Now for my bottom, I know that this has to be the same size as the top. So I kind of just eyeball it, and I go out a little bit, and then I really want to be careful when I close up my shape to make sure that this line is parallel to this line. And that's all right. I didn't do a bad job there. Not perfect, but close enough you can tell that what I'm trying to make here is a parallelogram. And that's what I want for yours. I want for somebody to look at it and say, oh, they tried to draw a parallelogram. B says, what is the perimeter of the parallelogram shown here? So theirs is tilted the other way of the one that I just drew, and they have it labeled here as 3 inches and 4 inches, and you need to find the perimeter. So pause me right here, try to solve this on your own, and then come back when you've got the answer. To find the perimeter, we have to add all 4 sides. So I'm adding 4 plus 3 plus 4 plus 3. So let me teach you now my perimeter trick. They usually only label 2 sides. I add those 2 sides first. So 4 plus 3 gives me 7 inches. The problem with this trick is that often kids will stop here and they'll tell me the perimeter is 7 inches. And you'd be wrong, because I only measured half of the perimeter. I know that this side plus this side is also going to be 7 inches. So when I do my just add the numbers they give me trick, then I automatically say, now I have to double it. So 7 plus 7 gives me 14, and so my perimeter is 14 inches for this one. All right, problem C says, what shape is not a parallelogram?
Hey Jennifer, can you come to my office? Addison's mom is here.
So we have it looks like a diamond shape. This is the first one. They want to know, is this a parallelogram? Are my opposite sides parallel? Yes, they sure are. That looks like a parallelogram. The next one we would call a kite shape. Is this a parallelogram? It looks close, but let me tell you, a kite shape, these sides are not quite parallel, because if I would continue this and continue this, they're going to meet up here. So that tells me they are not the same distance away for the whole length of them. Kite shapes are not parallelograms. The next one is a rectangle, but they have it twisted a little bit. So it doesn't you're used to seeing rectangles like this. The book's going to try to trick you and show you rectangles like this. Does turning it change the fact that it's a rectangle? Nope, it's still a rectangle, and rectangles are always parallelograms because their opposite sides are always parallel. That's part of what makes it a rectangle. So this is a parallelogram. And the final shape it shows us for this question is that this is kind of the standard parallelogram. We don't have another name for it other than parallelogram or quadrilateral. But quadrilateral is very general and refers to anything that has four sides. So if you saw this shape and they said name that shape, you would call it a parallelogram. Versus if you saw this shape and they said name that shape, it is a parallelogram, but we would call it a rectangle because it's a more specific type of parallelogram. All right, the last one we are going to look at together is another picture of a parallelogram, but this one we're going to talk about the angles. So they call it Q, T, R, S. And the question says, which angles in this parallelogram are obtuse? I want you to either write it down or call it out. Which angles are obtuse? Remember, obtuse, big, fat angle. So we've got T and R are obtuse. And our last question, which angles in this parallelogram are acute little angles? Call it out or write it down. Q and S are acute little tiny angles. All right, boys and girls, your next assignment is to start your written practice, which begins on page 358 of your textbook. I hope you have a great day, and I'll see you soon.